All right. So this video we're going to go through topic on inheritance, and a lot of this chapter wraps up one of the main topics in AP in inheritance and code reusability. These are some of the big keystone ideas of the entire point of object-oriented code. So this video is just going to go through some notes and some sample questions with you guys. So inheritance, we start off talking about superclasses and subclasses. So right here you got a student, and a student is the superclass. And you've got different types of students, which are subclasses. So you got a grad student is a student, and an undergrad student is a student. So those are called is relationships, okay? Now, a student is a grad student. That may be true in some cases, but not all cases. For instance, you high school students are not grad students, okay? At some point you may be, but right now, you're not a grad student. Whereas all grad students are students, and all undergrad students are students. So at the top, you've got your hierarchy, your superclass, and then everything below it are subclasses. Now, the idea of inheritance is that you want to be able to define all your variables and methods that all grad students and all undergrad students would want at the superclass level, and you'd only write it at the superclass level, at the student level, and then the grad student and the undergrad student or undergrad student could inherit that code, and then you don't have to write the code in both subclasses, okay? So let's kind of go through and read what this says. It says inheritance defines a relationship between objects that share characteristics. It is the mechanism whereby a new class called a subclass is created from an existing class called a superclass. Okay, so you create the grad student from the student class. Okay. The subclasses, they inherit characteristics of the superclass. Okay, so that's where you'd only have to write the code once in student, and then grad student would inherit that code, and so would undergrad. And I've said that kind of a couple of different ways now. So it provides for an effective mechanism for code reuse. That's a huge concept. Okay, from here on out, basically, we want to make our variables private, and this is going to get into an idea called encapsulation, which I'll talk about in a second. But let's look at this. We got a student class. There's a constructor with no arguments, meaning nothing's being passed in. And all we're doing is we're saying the name, my name to blank, my tests, and then we're making it an array integer, an array that holds integers, with the number of tests being 3, and my grade is equal to grade. Okay, and then down here we have a student. We have a constructor that has arguments, so we pass in the name, the tests, and the grade. Here we've got ourselves public accessor methods. So we're getting the string, getting the grade. Right here is a mutator method where we can set the grade, and we can compute the grade right here, and we can get the test average right here, okay? So, that code's real simple, no problem. You've seen this from intro to programming, okay? Maybe this is a little bit, newer with the for each loop. Adding up all the test scores into a total and dividing it by the number of tests. That gives you the average, okay? That's no problem. All this stuff is really easy, okay? Now, where it gets new is, let's say we have an undergrad student, okay? That extends student. The word extends means that, this is the subclass of student, and undergrad's going to inherit everything from student, okay? What is it going to inherit, okay? Well, what's really cool is that all the public methods that student has in it are available now to undergrad. Okay, so undergrad can access get test average. It doesn't access the compute average, because there's something called overriding that we do here. Here's compute grade. For an undergrad, their grade is computed by, if it's greater than or equal to 70, they pass, else they fail. If it's just a student, this is how you compute the student's grade. So last semester, we talked about a topic called overloading methods, where you can have the same method name with different parameter arguments being passed in, or they could be of different types. So it's, maybe one of your methods, it could be have like ints being passed in, where another one could have doubles being passed in. Okay, that's overloading. Overriding means that undergrad is not going to inherit the compute grade from student. It's going to compute its own grade inside here. But undergrad will inherit get test average. It will inherit set grade, get name. So you only have to write get name, get grade, set grade, and get test average in the superclass student, and then undergrad can use all those methods, and you don't have to. So again, this saves a ton of work. Again, I've always said that in school you're going to use little rinky-dink programs, and maybe you only use 3 or 4 files. But in the real world, if you were at Google or like Microsoft or something, you may have programs that are hundreds of programs, and you do not want to have to write code in every single file that you create. You just want to be able to write it in one file and then have your subclasses inherit that information. You want them to inherit those methods, and then they can use it. Okay. If anybody in here is familiar with HTML, this is the same type of idea with cascading style sheets. You create a cascading style sheet, and then each HTML file that calls the style sheet can use all of its properties, okay? So you see this idea of inheritance and reusability used in all sorts of different computer languages. Because writing code over and over and over and over again, it's too much of a pain and too much to manage. And then what happens is your subclasses are just semi-customized to do what they need to do. Okay? Let's keep going, because this is kind of what I talked about. So we talked about an undergrad student is a type of student. It inherits all the methods and variables from the student superclass by using the word extends. Okay? Notice that the student instance variable, my name, my test, and my grade are defined as private. Okay? Oh, I don't want to do that. Sorry. So the word private is important. Okay? Undergrad cannot directly access my name, my tests, my grade, because they are private variables. From here on out, we want to make our variables private. Okay, when we start getting into inheritance, we want to use private variables. The way that you can change my name, my test, and my grade, you can't just go into the undergrad class and say my name equals Seeley. It won't work because my name is a private variable. But what you can do is you can use the superclass's public methods. So you can get the name. Is there a set name in here? There might not be one. That was a bad example. If there's, yeah, I can't set the name in there. How about set the grade? So in the undergrad, I can set and change my grade by calling the public method setGrade. Okay. This whole concept I just explained is called encapsulation. Okay, so let's read about this. Notice that student instance variables, my name, my test, and my grade are defined as private and are therefore not directly accessible to the method in undergrad class, subclass. This is known as encapsulation. Encapsulation is the technique of making the fields. You're making the fields in a class private and providing access to the fields via public methods. If a field is declared private, it cannot be accessed by anyone outside the class, thereby hiding the fields within the class. For this reason, encapsulation is also referred to as data hiding. Encapsulation can be described as a protective barrier. So when I think of encapsulation, I think of a capsule. You've got a barrier that holds all the medicine inside, all right? So that's kind of what I think of, all right? It acts as a protective barrier that prevents the code and data being randomly accessed by other code defined outside the class. Access to the data and code is tightly controlled by an interface, okay? The interface is going to be, you know, what you build in main, you could have them enter names and enter grades and that kind of stuff, all right? It's what the user does to enter the information in, okay? The main benefit of encapsulation is the ability to modify or implemented code without breaking the code of others who use our code. With this feature, encapsulation gives maintainability, flexibility, and extensibility to our code. In the example above, the undergrad subclass can directly invoke the public accessor and mutator methods of the superclass. So invoke, once the object of undergrad is created in main, that object can then use the accessor and mutator methods that are public in student, okay? Thus, the undergrad subclass uses setGrade to access indirectly and modifies myGrade, okay? We talked about overriding in the superclass. So a method in a superclass is overridden in a subclass by defining a method with the same return type and signature, name and parameter types. For example, the compute grade method in undergrad subclass overrides the compute grade method in the student superclass. So at runtime, when you compile it, the compiler knows that when an object of undergrad calls compute grade, it knows to go to the undergrad compute grade because of the concept of overriding. Okay. Let's look at constructors. Constructors are never inherited. Okay. If no constructor is written for a subclass, the superclass default constructor with no parameters is generated. Okay, let's read that again because this is likely going to be an AP question. If no constructor is written for a subclass, the superclass default constructor with no parameters, that means nothing's being passed into it, that gets called, okay? So a superclass's default constructor or no arg constructor is automatically called just before the subclass's constructor executes. So we have a superclass 1, it does this. This is the superclass constructor, okay? We have a subclass 1 that extends superclass, and subclass says this is the subclass constructor. Based off of the rules that I read up here, the Superclasses constructor, no arg constructor gets called right before the subclass. So if I run this program, I create an object, subclass object, and I display it, it would display this is the superclass, and then it would display this is the subclass constructor, all right? You'll have to memorize that. If super is used in the implementation of a subclass constructor, it must be used in the first line of the constructor body. Okay, so if no constructor is provided in a subclass, the compiler provides the following default constructor. Okay, you're going to have to memorize that. All right, so in this example, now I'm going to just go through, I think, some questions. I don't think I have anything else to really, well, a little bit of like wrap-up lecture, but let's go through some of these questions because I've got another page of questions too. So number one, we've got a bank account. Okay, it's got a couple different constructors, one that just sets my balance to 0 and another one that passes balance in and sets my balance to the balance. We've got a deposit withdrawal, mutator methods, and an accessor method in get balance. So any subclass that inherits bank account would have access to these public methods right here: deposit, withdrawal, and get balance. It cannot directly change my balance, but it could if it used the deposit or the withdrawal methods. Okay, it can change my balance by doing deposit withdrawal. Okay, so savings account extends bank account. So savings account has access to the add interest, but it also has access to the bank account's deposit, withdraw, and get balance methods. Okay. A checking account extends a bank account. So let's see. A checking account has a different type of withdrawal method. Okay, so it's going to override it because a fee of $2 deductive withdrawal leaves balance less. So basically what they're saying is you have to have a certain amount of money, and if you withdraw too much, you're going to have a fee. Whereas a bank account, you can withdraw all you want as long as it's probably greater than 0. But this is a little puny program, so it's not programmed correctly. But whatever. It's just to, give you an idea of how this works. Of the methods shown, how many different constructor methods can be invoked by savings account? Okay, well, I gave you the answers down here, but let's look at savings account can access 1, because it's non-constructor, right? So it asked how many non-constructor methods can be invoked by the savings account. Well, 1. These 2 are constructor methods, so those aren't counted. So 1, 2, 3, 4. So those are the 4 methods that it can access. All right, and so clearly the answer is D, and it explains why. Okay. 2 of the following correctly, which of the following correctly implements the default constructor? It's got to be 2 and 3. 1 doesn't work because remember, super has to be called before you can do any sort of assignments. That was explained. If super is used in the implementation of a subclass constructor, it must be used in the first line of the constructor body. Okay, that's explained there. Okay. 3, which is a correct implementation of the constructor with parameters in the savings account? All right, well, what does savings account inherit? Well, we probably want a balance, okay? So we want to be able to super in the balance from the bank account class, and then you can assign my interest rate to the rate that's being passed in, because right here, wait, savings account. Savings account has a balance that's passed in, but since balance is supered in, you have to use super balance, and then rate would be my interest rate equals rate right here. Okay? Which is the correct implementation of the checking account constructor? Well, what is checking account doing? Checking account, let's look at it again. Checking account accepts a balance, so you can super in the balance. Super in the balance. You can always do this. You can always use the default constructor, super like that. That works. And even if you don't use it, it gets called automatically. It just sits there, and that's kind of hard for kids to understand. You can either put it in there or not. Either way, it's going to get called. And when it gets called, that basically happens. The balance gets assigned to 0 because this is the no arg constructor. Okay, that's kind of funky that it does that in the background, but it's something that you're going to have to memorize. Okay, and that will explain it right here. So implementation 3 works because super is automatically called as the first line of the constructor code if there is no explicit call to super. Okay, so just memorize that. All these are good, even though this one doesn't look good because you're like, well, super didn't get called. Well, yes, it did. It's just not being shown there. Java automatically does that for you. So 5, which is correct implementation code for the withdrawal method? Withdraw, what does withdrawal do? For the checking account, fee of $2 deducted if withdrawal leaves balance less than min balance, allows for a negative balance. Okay, so if it's less than 0, we want to be able to withdraw from the superclass, and then if the balance is less than the minimum balance, then withdraw the fee as well. Okay. Checking account doesn't have a withdrawal method in its class. It has to access it through its superclass, the bank account. Okay. So, and you guys can kind of read through why the others would be incorrect, okay? Like A, my balance is private and it's only known by the superclass, okay? You can't just call my balance. You have to use get balance, okay? Get balance is inherited in, okay? So read through these and understand why C is the answer, okay? And let's see if this wrap-up stuff. Quick rules for subclasses. Subclass can add new private instance variables. A subclass can add new public, private, or static methods. Subclass can override inherited methods. Subclass may not redefine public methods as private. A subclass may not override static methods of the superclass. A subclass, so you can't override. Remember that. Static methods of the subclass, the superclass. Sorry. A subclass should define its own constructor. Even though if it doesn't, it will inherit from the superclass. A subclass cannot directly access private members. This is a huge key. You cannot access private members, and that was question 5. You have to be able to call the public methods to access and change those private method or variables up. Declaring subclass objects. You got a student, new student, a student. So a student is a student, but you could do it like this too. A student is an undergrad, okay? This works because an undergrad is a student. Note that a student is not necessarily an undergrad student, therefore the following declaration is not valid. Okay, you can't do it backwards. This topic I'll go into later in the unit. This stuff starts to get into what's called polymorphism, but that goes beyond the point of this video. I want this to just be an introduction to inheritance. So let's start kind of going through. I'm going to put in sketch screen here. So here is the first line of class declaration. What is the name of the superclass? What is the name of the subclass? So this is the superclass, truck. Super is truck. Subclass is vehicle. I spelled that wrong. Vehicle. Okay, sorry. Sorry, I even did all that wrong. Oh my gosh. Gonna confuse you guys. Where's the eraser? Did that all wrong. Read that too fast. The vehicle is the superclass. And the idea of the superclass, it's more broad. It encompasses everything. Okay. The truck is a specific type, so more specific. Okay. So a truck is more specific than a vehicle, okay? So look at the following class declaration and answer the following from them. I gotta go in and scroll down. In this case, we have a shape, that's the superclass, and a circle is a specific type of shape. What's the superclass? Superclass is shape, subclass is circle. Okay, so let's do the UML model real quick. The UML model, we'd have shape, and here we have circle, and you have that type of relationship. This means is a, okay, and inside I don't like this because I can't go up and down, and it does that kind of stuff, but maybe we just do it right here. Let me. We got, let's do this again real quick. We've got shape. Here we've got circle. Okay. The shape has access to set area, and it's passed in a double A and a get area. This one has set radius and get radius. Okay, again, is a relationship. So the circle has access to that. This is private, so then the only way you can change the area with a circle is through its public methods. Okay. So we did that. When a circle object is created, what are its public members? So its public members are set radius, get radius, and set area and get area because it inherits everything from shape. Okay. What members of the shape class are not accessible to the circle class's methods? What members of shape? Okay, so area is private, So circle can't access area directly. It has to access it through its public methods, set area and get area. Okay. What members of shape are not? Never mind. Assume a program has the following declarations. Okay. Indicate whether the following is legal or illegal. That's legal. That's legal. Let's see here. Wait, let me. Wait. Set radius. Is that part of? That's part of circle, right? Yep. So a circle can call set radius, but a shape cannot. That's illegal. A circle can get the area, and a shape can get the area, because a shape knows, yeah, the shape can get those. But again, the shape cannot call either of these methods. So the illegal one here is shape trying to call set radius. Okay, class B inheritance from class A. Okay, so let's kind of draw this out real quick and then we'll be done with this one. So we've got the superclass A and then we've got the subclass B. The order in which the class's constructors execute when B is created. So it would do this super. It would do this constructor first, the no arg one, right? And then it would do this one. So it would do A's constructor and then B's. I don't know how they want me to answer that, but other than that, it's pretty much what we're doing. All right, so that's it for this video. Okay.